going to be presenting on the chemistry of coffee and coffee roasting. So coffee is a very popular beverage here in the States as well as around the world. It's actually the third most consumed beverage worldwide, preceded only by tea and water. It's also a very large industry. Around 153 million 60-kilogram bags are exported worldwide each year. So very large industry, and it is widely used for its stimulant effects among other things. So where does coffee come from? The beans are actually the seeds of the coffea plant, so it produces a cherry, and the seeds of the cherry are what we think of as the coffee beans. There are around 70 species of the coffea plant, but we only use 3 of them for their coffee beans. Coffea arabica is the main one that we use. 75% of our coffee comes from this species, followed by the canephora and liberica. This plant is indigenous to what is known as the bean belt of Central and South America, Africa, the Middle East, and Asia. And so the main sources of our coffee beans are Ethiopia, Brazil, India, Vietnam, Mexico, Guatemala, Indonesia, and Sri Lanka. So caffeine is probably the most well-known organic compound in coffee. It is actually the most widely used stimulant in the world. There's around 95 milligrams in an 8-ounce cup of coffee. This is just an average number. It's a bigger range just depending on several factors, such as the maturity of the bean, the harvesting process, even the species that it comes from. But this is just on average how much caffeine is in 1 cup of coffee. So there have been some benefits associated with caffeine consumption, including combating sleep inertia, which is the sleepy feeling you feel right when you wake up. So that's why some people will reach for a cup of coffee. Increased alertness, increased learning ability, and improved mood have also been associated with caffeine consumption. However, there are some drawbacks that have been found, including a development of a dependence on caffeine. And so then when they're no longer consuming caffeine, they may experience some withdrawal symptoms such as headaches or mood depression. And there has also been some studies finding that there is a sleep disturbance associated with caffeine consumption. So there are 10 main steps in getting our coffee beans. So the first is obviously the planting of it, the harvesting of the coffee cherries. There's a couple different ways that this is done, either strip picking or selective picking. So the selective picking is more labor intensive as it has to be done by hand, but this ensures that all the beans are kind of the same maturity and of just a higher quality. The beans are then processed, dried, either in a machine or just in the sun, milled, so they're sorted kind of according to their size, and then they're exported around the world where they are then roasted and then ground into and brewed into a cup of coffee. So the decaffeination process happens when the beans are still green. So before they have been roasted, there are 3 main ways that this is done. So just with water and steam. The second is with use of an organic solvent. This is the most commonly used as it's just the most cost efficient way. So the solvent is usually ethyl acetate or methylene chloride or dichloromethane. And the final way is also nanofiltration. So this is a newer method using a semi-permeable membrane to extract the caffeine. But again, using an organic solvent is just the most efficient and commonly used practice. So the roasting process is really the most important step in determining the final kind of character of the coffee, like the aroma, the taste, and texture of it, and several things will be determined in this process. So there's 2 main chemical reactions that will happen. The Maillard reaction, or non-enzymatic browning, will occur between 140 and 165 degrees Celsius. And then this is followed by caramelization, which will happen around 170 degrees Celsius. And this is when the sugars, which are mainly sucrose in the coffee beans, are broken down. And the first crack is really when the coffee bean literally cracks, and so that's how they know that this process is happening. So the Maillard reaction, we're going to talk about 3 main steps. So the first is the formation of a glycosylamine, and so this is a reaction between a reducing sugar, usually glucose, and an amino acid. And so this is a dehydration reaction, so the loss of water. Then the glycosylamine formed in the previous step can undergo two isomerization reactions, and this is called the Amadori rearrangement. So the imine on the glycosylamine will tautomerize to form the enamine, which also is forming an enol as there's an adjacent alcohol, which then can tautomerize to form the keto form, and this is known as the Amadori compound. Following this, the Strecker degradation can happen, and this is reaction between dicarbonyls that have been produced in the Maillard reactions and reactions of those dicarbonyls with amine groups, and this results in the production of aldehydes, which are a key component in flavoring of coffee, one of them. And so this reaction in particular shows the formation of acrylamide that can happen. This is an undesirable side reaction that can happen, as acrylamide may be a carcinogen, so this is something that is not desirable that may happen. So volatile compounds, there's over 900 of them that are produced in the Maillard reactions, and these are what are really the volatile compounds are what are responsible for the familiar and unique aroma of coffee. So depending on the groups, will have different aromas. So aldehydes are typically give off a fruity aroma. Furans will give a caramel aroma. Pyrazines will give an earthy aroma. Sulfur-containing will give a roasted aroma, and glycol will give a smoky aroma. So there are also non-volatile compounds that are found, and the main one is melanodins. So that's what gives coffee the dark roasty taste and appearance. These are these are only produced in the Maillard reactions, and this is just their general chemical compound look. And so then there's also the alkaloids. Caffeine, as discussed earlier, is one of them, and then trigonelline is a big contributor of flavor. So this trigonelline will react further to form furans, pyrols, and alkylpyridines, and these will react further and will form be responsible for all the varying flavors of a brew of coffee. Also the carbohydrates. This mainly in coffee is sucrose, and the balance of these, how many there are, will kind of determine the sweetness and bitterness, kind of the balance of those of the brew. Lipids, also kind of referred to as coffee oil, are responsible for the consistency and what is called the body of coffee. So it's kind of the creamy-ish taste or sensation that you get when you drink coffee. And as well as acids. So chlorogenic acids are the main acids that are found in coffee, and these react to form lactones and cinnamic acids, among several other things. These are the main things that they will react to form, and these are also large contributors to the flavor of coffee. So this is just kind of an overview of, you can see how the various components of coffee change during the roasting process. So the polysaccharides, the sugars, are broken down during the coffee roasting process. As well, so the carbohydrates are broken down. Lipids are fairly stable, so they remain pretty much the same. The free amino acids are, obviously, they are reacted in the Maillard reactions, so they are used up. Proteins are pretty much not, they're pretty stable, left alone. Chlorogenic acids, they also, as we talked about earlier, they react, and so there's less in roasted coffee than before. Caffeine is pretty much stable. Trigonelline reacts partially, and then fatty acids kind of remain, they react a little bit but remain kind of the same. Some minerals are produced in Maillard reactions, and then of course the melanodins are just they were not present before because they were produced in the Maillard reactions. Thank you guys.